Fuel cells and corrosion. Fuel cells that power hydrogen vehicles and buildings only release water, okay, H2O, as their product, which is obviously clean environmentally. If this is going to be our reaction where we just produce water, I've done that over here. If water is on the product side, that means we have to have oxygen and hydrogen on the left side as well, on the reactant side, so that it doesn't violate the law of conservation of mass. That means we're already given here a half reaction. This here will be the reduction half reaction, because as you can see, electrons are on the reactant side. That means this one here has to be the oxidation half reaction. So what do you think the oxidation half reaction have to look like in order to sum up with the reduction half reaction over here in order to create our overall reaction? First thing we got to do is make sure this is balanced. It's not balanced over here, so I'm going to be putting 2 oxygens on the right side. That makes this one over here 2 as well. So we've got 2 times 2 is 4 hydrogens, so now they're all balanced out. So now let's figure out what this reaction has to be. This 2H2O went down over here, it carried downwards, which means we are good. The problem is, where is this H2? Where did this H2 come from? It must have come from the reaction up here. So if I had a yield symbol over here, this H2O, this H2 must have been this H2 up over there, okay? So then, how about this 4H plus and this 4 electrons? I don't see it down here in my overall reaction. It must have mean that this one must have been over here on the product side, and this one over here must have been on the product side as well. That way that this and this can cancel, and this one can cancel. So let's give it a try. As you can see, I've done it over here. The reason why I did 2 H pluses and 2 electrons as opposed to 4s is because I only have 2 atoms of H2 on the reactant side. Okay, so now I'm just going to multiply the whole thing by 2. So this one then becomes a 2 coefficient, this one becomes a 4 coefficient, and this one also becomes a 4 coefficient. So now I can cancel this one and this one out, and then this one and this one out. So now all I'm left with, carry it downwards, 2H2, as you can see over here, 102, 102 down over here, and 2H2O, 2H2O down over here. Obviously, our formula is to just get our cathode voltage, so I'm going to be putting it over here, and our anode being subtracted, that voltage is going to be this one over here. As you can see in the previous video, link it in the description, that the voltage for the H2 half reaction is always 0. So I'm going to be putting 0 over here, so I just sum them up, so I end up getting 1.23 as our voltage. Now, rusting is corrosion but of iron due to oxidation. As you can see, this here is on the product side, so this here is the oxidation half reaction. This here, this electrons on the reactant side, so this here is the reduction half reaction. Just like the PEM fuel cell, rusting is the same thing. You just add them up together, you get an overall reaction. This here is rusting. Now, is rusting combustion? Nope, because combustion needs to release a significant amount of heat and light and is a rapid reaction. Obviously, rusting is not like that. Try these 2 questions on your own. I'll be giving you the answers now. These are the answers. I'm slowly scrolling down.